Let's go ahead and look at some antiderivatives that have composite functions. And what we're going to be doing is we're going to rewrite the function in terms of u. And that will allow us to be able to take the antiderivative of a composite function much easier. So again, let's first start off being able to identify the inside and the outside function. So in this problem, your inside function, is whatever's being raised to the power, which is x cubed plus 1. So I'm going to call u the inside function and call that x cubed plus 1. Now, we are going to rewrite everything in terms of u. So I'm going to go ahead and take the derivative of u because I'm going to need a du there as well. So I'm going to put an intermediate step here. So the derivative of u with respect to x will just be 3x squared. And then what I'm going to do is I'm going to solve this for du. So basically that just means move that dx over. So du is 3x squared dx. So this allows me to rewrite the original problem, everything in terms of u and du. So notice what I can do is this piece becomes u. So I have u to the fourth. That takes care of that. Now everything else left over, you cannot integrate u's if you have x's mixed in. We have to have it also in terms of du. But notice, okay, x squared dx, which is what I have left, is really part of du. So I can solve that for just the x squared dx. So notice this x squared dx is the same as du divided by 3. So I'm going to go ahead and put that there. And the integral symbol is still there. So this is how I rewrite that in terms of u. And I'm just going to clean that up a little. That 3 is just a number, so I'm going to pull that out. So now I have everything in terms of u's and du's. So I can take this antiderivative pretty easily. How do we take the antiderivative of u to the fourth? We just add 1, divide by the power, plus c. So that's your antiderivative in terms of u, but we need our final answer in terms of x's. So we're going to replace what we plugged in for u. So I've got 1/3. Your u is really x cubed plus 1 to the fifth over 5 plus c. Okay, so let's go ahead and practice doing that with the set of problems we've got on this page. So let's look at the next one. So remember we said for a trig function, your inside function is going to be the angle. So I'm going to start with u. And remember, I am going to take this derivative. So du dx is really 2. And I'm going to solve this for du always. So I'm going to just move this here. So going forward, I'm going to go straight to this step. Basically, all that's happening is I'm moving that dx over. So I'm going to get rid of this. Okay, so I've got u du. Let's go ahead and rewrite everything in the problem. So instead of 2x, I'm going to write that as u. So I've got cosine. I need to replace dx. Well, let's look here. Dx is really the same as du divided by 2. So I'm going to plug that in for dx. So I kind of cleaned that up, pull that 1/2 in the front. So I have 1/2 cosine of u. What's the antiderivative of cosine? It's just sine. 1/2 sine of u plus c. And then instead of u, I plug back in what the u was, which was 2x. So that's how I get to my final answer. Okay, let's try the next one. Same thing. So what's my inside function? So my inside function is 3 plus 4x. My du is going to be really 4. And then remember, I said I'm going to skip that intermediate step and just move that dx right away. So let's rewrite this problem in terms of u. So this becomes u to the third, right? Dx is really du over 4. So this is my rewrite. I'm going to pull that 1/4 in the front and write it like this. So antiderivative is really 1/4 u to the fourth over 4 plus c. But I do want my final answer in terms of x's. So let's plug back in the u, which is 3 plus 4x to the 4 plus c. And just go ahead and leave your answer like this for now. Okay, next one. Inside function is 1/3 x. Du would just be 1/3, and again, the dx, we're going to move over and leave it here. So let's rewrite this. Oops. So the 1/3 x becomes u. I've got cosine. Dx would really be the same as 3 times du, so I'm going to put 3 du in for dx. And I always pull numbers that are just being multiplied in the front because I can multiply it later. So there's my rewrite. Antiderivative cosine is sine. I need my answer in terms of x's. U is the same as 1/3 x, so I'm going to plug that back in. So this is the answer that I'm looking for. Okay, next one. Okay, I would rewrite this. Anytime we have things raised to a power on the bottom that's not just 1, I typically bring it to the top. So think of it like this. So I can see my inside function is what's being raised to the power, 1 plus square root of x. The derivative is going to be 1/2 x to the negative 1/2, and move that dx over. And let's go ahead and do the rewrite. So notice what happens here. Let me get rid of this for now. Okay, so remember I brought this to the top. So really this is u to the negative 3. So that takes care of that. Notice I have this left. 1 over square root of x and dx. Well, notice, isn't that what all of this is? 1 over square root of x dx. Really, just move that 1/2 over. So 1 over square root of x dx is really the same as 2 du. So my rewrite looks like this. I'm going to add 1, divide by the power, plus c. Go ahead and I'm going to clean this up a little bit. So really it's a negative 1, and then over u, which is 1 plus square root of x squared plus c. I plug this back in and move that negative exponent to the bottom. Okay, last one here. Your u is the x cubed minus 1. The derivative would just be 3x squared. And again, move that dx over. So this becomes u to the 7th. X squared dx is really du over 3. So I'm going to put that here. So let's pull that 1/3 out. So this is my rewrite. Antiderivative is 1/3, add 1, divide by the power. And I'm going to leave it like this and plug back in the u. So this is my answer in terms of x's.